Here we are looking at a graph to find relative extrema, absolute extrema, and their values. So we're going to address each x value. So I'm going to start off, we're looking on the interval from -1 to 6. That's where they ask us to look. So I'm just going to box in what that interval actually is. So we have the interval from -1 to +6. So we have this whole picture of a graph, and we're only going to zoom in on just this portion, the portion that they ask us to. That's our interval of interest. So -1 to 6, and we want to state what's happening at each x value. So I'm going to start with x equals -1, x equals 0, x equals 1, x equals 2, and just mark my way all the way up to 6. Just because it says to address every single x value, state whether it is a local, absolute, max, or min, or if it's neither. So from -1 to 6, our entire interval of interest, saying what's happening there. So looking at this graph, we want to just label what's happening, first of all, with the first derivative. So we want to find any critical numbers so that we can find relative extrema. Relative extrema happen at critical numbers so we'd want to find where those are. Absolute extrema happen at critical numbers or endpoints. Because for absolute extrema, we compare end behavior. Relative extrema only happen at critical numbers. Absolute extrema happen at either critical numbers or at endpoints. So looking at this graph, I'm going to start to label what's happening with the first derivative. Find each piece. So the first piece we have at -1 is falling left to right. So I'm going to label that as a negative first derivative. Then we have a soft peak, so I'm going to label this critical number. This is where the derivative is 0. I might have a relative max or min there, and maybe it's also an absolute max or min. So there's one of my critical numbers. And then my next piece is rising left to right. So I'm going to call that increasing. Then we have a cusp here, or a sharp corner. This is where f prime is undefined. The derivative is undefined there, but that could also be a critical number, right? A critical number makes the derivative 0 or undefined. So there's another critical number at that cusp. And then we fall left to right, so we have a negative first derivative again. And then we have this next piece is just a flat part of the graph. So the derivative at that constant part of the graph is going to be 0. Then we're going to look what happens after. It's rising left to right, so it's a positive first derivative. We have another cusp. This is where f prime is undefined. And then after that, we are falling left to right. So a negative first derivative. And now we can go through point by point and see what we have. Do we have a relative max or min, an absolute max or min, or neither? So starting with -1. -1 is the endpoint. Remember, relative extrema cannot happen at endpoints. only absolute extrema can. Kind of the same thing we wrote over there. I'm going to write it again just because sometimes it gets jumbled up in our minds. So looking at this, I might say, well, that looks like it's a relative max or min because I can see what's happening with the part of the graph that we're not using. We're only looking from -1 to 6. This is called our interval of interest. And yes, if we were looking at the whole graph, that would be a relative max because it does switch from increasing to decreasing. But we're not looking at that because that's our endpoint. We're ending at x is -1. So it automatically cannot be a relative extrema. So really the only question is there an absolute max or min there? Well, it's not an absolute max because I see points that are higher, and it's not an absolute min because I see points that are lower. So that endpoint is neither. It could only ever be an absolute max or min, could never be a relative extrema at an endpoint, and it's not the absolute highest or lowest point there. Okay, looking at our next x value, we're looking at x is 0. It is a critical number, so it could be a relative extrema. Also, if it's the absolute highest or lowest point, it could also be an absolute extrema. So it is a critical number that switches from decreasing to increasing. Any critical number that switches from decreasing to increasing is automatically going to be a relative min. Decreasing to increasing. Next x value that we're interested in is x equals 1. So right off the bat, that is not a critical number. It's increasing there. So it's not going to be a relative max or min. It's also not an endpoint with that as the highest or lowest. So this is just going to be neither. Our next x value is at 2. There is a critical number there. It makes the derivative undefined. So is it a relative max or min? Yeah, it switches from increasing to decreasing. So it's automatically a relative max. But the bigger question is it an absolute max? Well, let's compare it to the end behavior of the graph. Looking at the ends, this is lower, and also this side goes lower. So comparing my critical number to the end behavior, endpoints, it is higher than everything. So the more stronger relationship that we can call it, we would label this an absolute max. That's the bigger solution there, because you can have several relative max, but there's only one absolute highest y value, and that one is it. So it happens at that critical number. Okay, continuing down, we have x is 3, and the sign change there is decreasing to 0. Decreasing to a 0 derivative because it's a flat part of the graph. So is that going to be a relative max, min, or neither? It's going to be neither. It'd have to be increasing to decreasing to be a max, or decreasing to increasing to be a min, and it just doesn't have that sign change. Moving over to x is 4. Again, we have a sign change, but it's a 0 derivative to a positive derivative. That doesn't match the change we need. We need negative to positive or positive to negative, so that x value is also going to be neither an absolute max, absolute min, or relative max and relative min. The next point is a little bit more interesting because at x is 5, we have another critical number. So I might have a relative extrema there, and then if it's also the absolute highest or lowest point, it's going to be an absolute extrema as well. At that critical number, we switch from increasing to decreasing. So we have a relative max. Is it also an absolute max? So we would want to compare it to the end behavior. So we're looking on the interval from -1 to 6. We're going to look on that entire interval. Is that the absolute highest point you see? No. It goes much higher. On that left end behavior, it does go up higher than that point. So we would say that is just a relative extrema. It's not also an absolute extrema. So just a relative max. Our last point is an endpoint at 6. So again, it cannot be a relative max or min. Can never have those at endpoints. But is it an absolute max or min? Well, compare it to your relative extrema. So we had one relative min at 0. Is that relative min going to be the absolute min, or is it going to happen at our endpoint? So we want to compare our critical numbers, we had a few of them, to our endpoint, and the endpoint is actually the lowest point on the graph. So we're going to call that an absolute min. So we have an absolute min at the endpoint 6, an absolute max at that critical number 2, and then a couple other relative extrema. We had a relative min and a relative max outside of our absolute max and min. So the moral of the story, no matter how crazy the graph gets, if you have sign change at a critical number, you're going to have a relative extrema. If you compare your critical numbers to your endpoints, that will give you your absolute extrema. The absolute max and min are either going to happen at the critical numbers where you had your relative max and min, or it's going to happen at the endpoint or during the end behavior.